Hello. So here I'll talk about introduction to polar coordinates. Again, a lot of definitions here. The ordered pair r theta serves to locate the point P with respect to the pole and the polar axis. We refer to r and theta as polar coordinates of P, and we write P r theta to indicate that P is the point with polar coordinates r theta. You can think of r as your radius. And so this is your polar axis. This is the pole. The angle theta always goes from the polar axis counterclockwise, so that this point P of r theta is your radius and at a certain angle. Now, it is often useful to consider both rectangular and polar coordinates at the same time. Suppose that a point P, other than the origin, has rectangular coordinates xy and polar coordinates r theta. So in this case, here you have your y-axis, or when theta equals pi over 2. Here you have your x-axis. So this point right here is px comma y, or it's pr comma theta. So with this configuration, cosine theta is equal to x over r if and only if x is equal to r cosine theta. Same thing with sine. Sine of theta equals y over r if and only if y equals r sine theta. We have the circle centered at the origin. X squared plus y squared equals r squared. Tangent is your y over your x. So the relations between polar and rectangular coordinates, x equals r cosine theta, y equals r sine theta, x squared plus y squared equals r squared, tangent theta equals y over x. The distance formula for polar coordinates, and so if this point here is r1 theta 1, if this is theta up in here, and if this point is r2 theta 2, the angle inside will be theta 2 minus theta 1, and the distance between these 2 points. Now, note the law of cosines is a squared equals b squared plus c squared minus 2bc cosine a. The distance formula for polar coordinates is going to be d squared equals r1 squared plus r2 squared minus 2r1 r2 cosine of that angle. It's going to be the distance squared equals r2 squared plus r1 squared minus 2 times r1 times r2 times cosine of this angle. Polar equations for circles. Now, suppose that the radius of a circle is a, and that the polar coordinates of the circle are r naught and theta naught, or r initial. Okay, so the polar coordinates, the center is r naught theta naught. It has a radius of a, and it's going to go out to some point of r theta. Here, since the distance between the 2 points is a, we have r squared plus r naught squared minus 2 times their product times cosine the difference of the angles is equal to a squared from the law of cosines. Polar equations for circles. A circle with a radius a and center at r naught theta naught. This is the word I'm saying, naught. N-A-U-G-H-T. R naught theta naught. So a circle with a radius a and center at r naught theta naught is r squared plus r naught squared minus 2 times their product times cosine the difference equals a squared. And if the center for the circle is at the origin, then r equals a. So graph each point in a polar coordinate system, then convert the given polar coordinates to rectangular coordinates. So here we're going to graph these in polar coordinate system. So we have an r and a theta. Radius of 5, so we're going to go out 5. I'm going to want this for later. So the radius of 5, 1, 2, 3, 4, 5, and an angle of 45 degrees. So graph each point in a polar coordinate system. That satisfied the question. This would be about 45 degrees up, pi over 4 up, and it is 5 units away from the origin. You can get polar graph paper. Polar graph paper has these concentric circles on it. Now, convert the given polar coordinates to rectangular coordinates. Okay, so we know that so the x equals 5 times cosine of pi over 4 and sine would give us the same value. So convert the given polar coordinates to rectangular coordinates. Okay, that would be so one way to do this is to graph positive 5 comma pi over 4. Now, through each of these points in your polar graphing, What kind of mathematician does not have a ruler at his desk? So what's going on through the pole is a straight line. This point is positive 5 pi over 4. This point is negative 5 comma pi over 4. So that is the point that we desire. Okay. And then convert the given polar coordinates to rectangular coordinates. And sure enough, it is negative x, negative y. Well, let's convert these into rectangular. Cosine of negative pi over 4 is going to be a positive radical 2 over 2. But this is going to be negative radical 2 over 2. Because a negative times a negative is a positive. That's the point that we desire. The same x, the same y is going to be 45-degree angle. 5 units out. Convert the given rectangular coordinates to polar coordinates. Express answers such that r is non-negative and theta is in the first revolution. Tangent of theta is radical 3 over 3. So we have an r of 2 radical 3, and our theta is 30 degrees, or let's go with a pi over 6. So theta has to be pi over 6 instead of 30 degrees. These are radians. And r is non-negative. So we have this one is not possible. This is an undefined. I mean, yes, we can get a radius, but we don't have an angle measure. Thank you very much. Please go to tutoring.